Good morning. I'm Will Tobey. I'm a senior fellow at the Belfer Center for Science and International Affairs at Harvard University, and today's panel, or this morning's panel, will be on fissile material. We have with us today Mr. John Carlson of the Lowy Institute, who's a visiting fellow at Lowy. He was Director General of the Australian Safeguards and Non-Proliferation Office from 1989 until 2010, and the chairman of the Standing Advisory Group on Safeguards Implementation. Also, Dr. Chaim Brown of Stanford University, who has 33 years of management and consulting experience in the electric and nuclear power industry. He received his education in nuclear engineering, in chemical and nuclear engineering, nuclear chemistry, and in operations research at the Technion and Weizmann Institute in Israel and at Cornell University. And Dr. Tom LaTourette of the RAND Corporation. Dr. LaTourette is a senior physical scientist at the RAND Corporation, specializing in energy, public safety, and homeland security policy. I'm very pleased to be here at the Asan Plenum, which has managed to assemble some of the world's foremost experts on nuclear issues. In a sense, our topic, fissile material, makes this the most important session of the plenum. Without fissile material, there would, of course, be no nuclear future. On the other hand, fissile material as a topic is a physical fact, not a policy proposal or a challenge. It's a broad topic, and you will see from the discussants a variety of perspectives. I could recount for you in greater detail their significant accomplishments, but that would only delay your access to their thoughts. So without further ado, I'd like to turn to Mr. John Carlson.
Thank you, Will. Good morning, everybody. Can you hear me? I'm not too sure whether this is actually working. The subject, fissile material, is very broad. The subject, that's better. Thank you. The subject, fissile material, is a very broad one, and I guess the first issue I'd like to raise is what do we mean by fissile material? The fissile material is not actually a technical term in non-proliferation disarmament circles or in the safeguards world. I'd choose as the definition the one that's used in the context of the Fissile Material Cut-off Treaty proposal, which is that fissile material encompasses high enriched uranium, that's uranium enriched to 20% or more in the isotope U-235, and separated plutonium, that is plutonium that has been separated from irradiated fuel or targets by reprocessing. Production of nuclear weapons requires the acquisition of either HEU or separated plutonium. Therefore, either having fissile materials or having the means to produce them, namely enrichment and reprocessing, can present a proliferation risk. And fissile material can also present a risk of acquisition and use by terrorists. The terrorist risk has been recognised by the very long-running international program to minimise HEU in civilian programs, and more recently by the Nuclear Security Summit process, which was launched by President Obama in 2009. And as you all know, the second Nuclear Security Summit will be held here in Seoul next year. A lot of the emphasis at the first summit in Washington was on HEU. And I think a major question is whether sufficient is being done to minimise the risks that are involved with separated plutonium. At the first summit, or in the summit process, there's a great deal of reluctance by a number of countries to engage on plutonium issues. And I think the view was taken by some that to produce an effective explosive device from plutonium would be too great a challenge for terrorist groups, a view which I'd regard as both incorrect and in fact dangerous. So there's a dangerous complacency in the area of the handling of plutonium in civilian programs, in my view. For the future, the fast breeder reactor presents serious risks both for proliferation and for terrorism, particularly if the very high fissile plutonium produced in breeding blankets is separated, and if that material circulates in civilian programs. So, for a start, I think there's a need for technical measures to build proliferation resistance into any system that is used for recycling plutonium. And yesterday you would have heard some discussion of the pros and cons of electrometallurgical or pyro processing as an alternative to aqueous reprocessing, for instance. So I think one important way of addressing the fissile material problem is to look for technologies that reduce the risk of misuse of these materials. And a good start with plutonium is to look at recycle technologies that avoid purification of plutonium, but leave plutonium always in an isotopic composition and a mix with other materials that creates a barrier to its misuse. In addition, I believe we need institutional measures to address enrichment and plutonium issues. Any state that has enrichment and plutonium and reprocessing technologies has the potential to produce nuclear weapons. So I believe that for the future we must look at alternatives to national fissile material production programs. I think these issues are shown very sharply in the Iran case, that Iran is the subject of international sanctions because they were foolish enough to try to run a program in secret. But the Iranians and their various supporters have made much of the argument that Iran is entitled to operate whatever nuclear technology it wishes. And the fact is that if the Iranians had been smarter and had been open about what they were trying to develop at the outset, that there would be nothing that the international community could have done about the situation. And I think this highlights that we need to rethink what the NPT actually means, and whether it is a correct interpretation of the NPT that any party can operate any fuel cycle technology regardless of the proliferation risks and regardless of the intent behind that program. To say that Iran cannot have enrichment will not win international acceptance unless we also say wholly national programs run by anybody are undesirable in the longer term, and we should move towards an alternative to a wholly nationally controlled program. Fissile production capabilities represent a risk not only to non-proliferation but also to disarmament. The proposed fissile material cut-off treaty, which will prohibit production of fissile material for nuclear weapons use, will be a very important step. But in the longer term, I believe that that even in the weapon states we need to replace wholly national programs. While ever enrichment and reprocessing programs are under the control of a single weapon state or ex-weapon state in the future, that state always has the ability to very quickly reconstitute a weapons program. So increasing attention is being given to multilateral approaches. The IEA established an expert group that brought out a landmark study in this area in 2005, looking at the various multilateral approaches, and there are quite a number of variants. But I think that these will become increasingly important in the future. In order to persuade states that they don't need their own fissile production capabilities, clearly we need to address the very important issue of how to ensure energy security. How will the states that are operating nuclear programs be guaranteed that they will receive fuel as they need it? So there's much work to be done developing institutional structures as well as technical barriers to misuse of technology. But my own view is that a continuation of the past in the nuclear industry is not sustainable. That if we have proliferation-capable programs that are being run on a wholly national basis, then the simple application of safeguards by itself will not be sufficient to eliminate proliferation risk. So I'd conclude by saying the subject of fissile material is really at the heart of the proliferation problem, and is also at the heart of the wish to eliminate nuclear weapons, of the disarmament problem. And we need to look at new approaches to go as far as we can to eliminate the risk of misuse of these technologies. Thank you.
Thank you, John. I would have just one brief question before we turn to other panelists. Do you believe that pyroprocessing offers a difference in kind rather than degree versus traditional reprocessing methods in terms of proliferation resistance? And if not, do you believe that there is a prospect for such technologies in the future?
I'd have to confess to being a fan of pyroprocessing, but I'd make no claims that pyroprocessing is proliferation proof. I think it's very important to get our terminology right here. Proliferation resistance involves incorporating barriers to the misuse of technology. And one important barrier is time, for instance, so that if technology is being misused, there's warning time and the possibility for the international community to intervene. But that's quite a different proposition to saying that a certain technology is inherently incapable of misuse. There's no doubt that pyroprocessing can be used to purify plutonium. So claims to the contrary are incorrect. Pyroprocessing is more complicated to misuse that way, and there would be warning time. Is that enough, though? I mean, one of the questions is, warning time is very important, but warning time, at the end of the day, is only useful if the international community can act effectively. And I think that's one of the issues that Iran has thrown up, that we've certainly had ample warning of Iranian intentions, but to date, intervention has been ineffective. So I'd suggest that even a pyroprocessing program, which is clearly less of a proliferation risk on the surface compared with aqueous reprocessing, that even a pyro program should be operated on some form of multilateral basis rather than as a wholly national program.
Thank you. Dr. Brown?
Okay. Actually, to continue really on your question, I met the inventor of pyroprocessing in Idaho West some 27 years ago. And he told me about his technology. And he said, truly, it produces a co-process stream of plutonium and uranium. However, he says, I know where to turn this electric knob in this place, and when I turn it over, the stream separates and you get pure plutonium and pure uranium on the side. So that is to say that no technology is foolproof, and it really depends on how you use it or misuse it, and what barriers you put against misuse. But that's not the subject of my talk. I'm going to talk about uranium enrichment right now. On uranium enrichment, we are seeing two trends right now. One is the development of national enrichment plants, and the other is the development of multilateral enrichment plants. Let me go and discuss a little bit both of them. The push to restart a national enrichment plant occurred after 2004, when there was a push by the American administration to limit enrichment and reprocessing to countries that already had those technology in place. Consequently, though not for the only reason, several other countries that had dormant reprocessing plants rushed to reactivate them in order to grandfather them from any potential limitation that might come out of this policy. I should say that national reprocessing is quite allowed, that there's nothing wrong with it, assuming that it's done under the right conditions. It's not the case always. However, what we saw recently was the reactivation or a real success of completion of the Brazilian enrichment plant in Lesen, the reactivation of the Argentinian plant in Pilcancho. South Africa is looking at two different enrichment processes right now. One is a stationary nozzle and the other is centrifuges, let alone the laser technology that had some connection to South Africa. South Korea experimented with laser enrichment, and eventually the program was stopped and cancelled, but of course they know how to do it. Iran is developing significant enrichment capability, and just last week announced that it's going to install P2 or IR2 centrifuges in its new enrichment plant in Fordow. India is developing already its fourth generation centrifuges and already talking about the fifth and sixth generation centrifuges to be made of carbon fiber material rather than margin steel, and significant expansion of its enrichment capacity, quite significant. Pakistan, of course, increased a bit the capacity of its Kahuta enrichment plant, let alone significantly increase plutonium production, though I'm not going to talk about plutonium production here. We see Saudi Arabia even not excluding the possibility that when they build a nuclear program, it might include also an enrichment component. Evidently, there's some enrichment capacity in Israel, and that came into being with discussion of the reactivation of P1 centrifuges in Israel to plan out the possible stuckness virus attack on Iran. And on top of everything is the laser enrichment technology that's been activated in the United States with Australian support, as well as China, Russia, Iran, and several other places. So there's quite a bit of national enrichment plant activities. On the other end, there have been several examples of multilateral enrichment activities, some of them of long standing. The Eurodif and Sofidif enrichment plant in France were all multilateral plants under French control, but with the participation, both financial and commercial, of international partners. The laser enrichment system in the United States is developed by the Enrichment Technology Corporation, ETC, which in itself is an international corporation made of French and British participation. And ETC sells its technology both to Urenco and to Areva, for Urenco and Areva to compete with each other on enrichment using the same technology provided by ETC, but built by different arrangements, each one developed either by Arriva or by Urenco. The Russians developed the International Uranium Enrichment Center in Angarsk, though that's not going so well commercially. The German proposed a Multilateral Enrichment Sanctuary proposal, MESP. Again, it's a proposal, but it didn't yet find resonance anywhere in the world. The Gulf Coordination Council group proposed an enrichment plant for all Arab nuclear power plants to be built in the Middle East, and the plant to be located somewhere away from the Middle East, which is a very interesting concept on its own right. On the other end, you hear countries like Jordan talking about the Arab fuel cycle, and when I hear that, even though it's a nebulous concept, I sort of shudder. You don't know what it means. So, evidently, I would prefer to see regional enrichment centers rather than national enrichment center, or really multilateral enrichment center of whatever type. So the question is, how could a regional or multilateral enrichment center be facilitated? And this is my idea for it. I think there's a least resistant path for the construction of a multilateral enrichment center. And that involves a region or several countries in a region where they already might have few nuclear power plants operating in one or two states in the region. Northeast Asia is really an exemplar of that region. The countries that own nuclear power plants in any particular area might form together a procurement agency similar to the European Supply Agency in order to buy together uranium requirements for the operating nuclear power plants. If you pull together the requirements and present them to the uranium suppliers as one large package, you are more likely to have volume discounted and better conditions for your export. Eventually, this approach of a supply agency, which exists in Europe and which has been proposed for Argentina and for Brazil, could expand to include conversion services, eventually fabrication services, and in time, should an organization like this evolve and prove successful on a regional basis, it could be expanded to include also enrichment services. It could start by ordering enrichment services from foreign suppliers as a bundle for all the requirements of the region. However, eventually, the members of such a supply agency could approach an enrichment company and say, we have enough capacity in our region, spread out among all our countries, and this capacity justify you building an enrichment plant in our region to meet our own requirements. And at that point, should conditions evolve to that, that may be the least resistant path to eventually constructing a regional enrichment plant. There are, of course, several conditions and constraints under which such an organization might work should it evolve to that region. First of all, it will probably operate under what you call two-tier black box model. That is to say, there will be a commercial tier on top, which will manage the commercial aspect and the sales of the product. There will be a second technical tier, which will be controlled by the technology provider, be it an international enrichment corporation, where the data will be controlled by the International Enrichment Corporation and not necessarily transferred to the regional countries ordering the plant. An example is the LES plant in the United States, where the United States partners may not know the details of the laser enrichment technology, the centrifuge enrichment technology, which only the ETC Corporation knows. On the other hand, once the centrifuge started operating and they produce reliability data, it's not clear that the US government will allow that technology to be transferred back to ETC. So people could classify different aspects of enrichment technology and release it or not release it according to desires. So therefore, the black box activity will be there always in place. When we talk about black boxes, before I get to black box, another approach that could be made in terms of regional enrichment plant is to go to what is called partial enrichment. That is to say, the enrichment plant to be built to fill the requirements of a particular region of power plants could provide only partial enrichment of the total enrichment requirements. That is to say, if power plants did enrichment to the level of 5%, 4.5%, 4%, 3%, a local enrichment plant could provide enrichment for all those requirements up to, let's say, 2%, or what is called technically slightly enriched uranium. And the final enrichment to the specific requirements of each reactor could still be performed at the international cooperation sites somewhere away from the region. So this is called partial enrichment. That's one option. Another option to consider is what came out of the Multilateral Approaches program of the IAEA, which is called an enrichment bond. An enrichment bond was a British concept which tried to organize a promise, a contractual promise, by the host government of the enrichment plant to the people which will build enrichment plant in the region to say, if you, the regional countries, meet all your safeguard obligation, we, the host country of the Enrichment Technology Corporation, will not interfere for political reasons in the operation of that enrichment plant. So you need some kind of a political guarantee that if you build an enrichment plant in a particular region, its operation will not be stopped because of political constraints. And that is called, or the British called it, an enrichment bond. I talked about partial enrichment, I talked about black box, and I just like to remind you all that black boxes are not completely black. They come in what I call multiple colors. Depending on who the supplier is, on who the recipient countries are, there are conditions on release of some information or not release of some other information that will vary depending on the local conditions. As an example, when you build a centrifuge enrichment plant in a region away from the main headquarters of the technology provider, centrifuges cannot be shipped assembled. They are shipped unassembled in separate kits, and then they have to be assembled on site. So, it is possible to disclose or not to disclose the technology of the centrifuge design. It is possible to disclose or not to disclose the way the centrifuges are being assembled on site. It is possible to disclose or not to disclose the technical tricks that are associated with the layout of the entire centrifuge plant, including distances from stations, including the location of the feed, product, and waste station of the plant, and so on. And it is possible to disclose or not to disclose reliability and performance data of the plant once it started operating. Evidently, depending on the condition of the local situation, some information will be shared more on all of these different aspects, other information might not be shared. Because of this possibility of sharing some or not sharing some information, which will depend on local conditions, I refer to it as a multicolored black box. So that's something that has to be considered. With that, let me simply say, end my discussion, and saying that we looked at there are two possible ways of expanding an enrichment capacity worldwide. One is based on national enrichment plants, and some of those enrichment plants could be used for not legitimate purposes, but let's say latent weapon processes. And what we'll see in that case is evolving the IAEA system of the NPT and NPT safeguards into a system of cafeteria-style NPT, where some countries will choose to completely meet all their obligations except in one particular session or one particular subject, and other countries might choose to fulfill their obligation except some other part which they don't like to fulfill. National facilities eventually, particularly with the need for latent facilities, could eventually evolve into what I call cafeteria-style NPT. Multilateral approaches are better in that the different countries could supervise the operation of the plant and control each other to make sure that no diversion or proliferation attempts are made, so they are more stable. The future will not be either white or black, it will be a combination of both. There will be national facilities, there may be one or two multilateral facilities, and the impact of all of this on non-proliferation is waiting to the future to be found out. Thank you.
Thank you, Dr. Brown. I also have a question for you, and that is there any lesson to be drawn from our experience with the original multilateral enrichment facility Urenco, which was the source of what I believe to be the greatest proliferation disaster in our brief experience with such matters, the AQCON organization.
Well, I think you have to control the technology better. That's the major lesson that we learned. Urenco let AQCON and some of his colleagues walk away with at least 2 centrifuge technologies, and the consequences are quite severe. The other lesson we learn is that retired engineers that try to supplement their income, unless to some extent supervised, could do a lot of harm on their retirements. So retiring without employment could be, though not necessarily be, a recipe for some unexpected results.
Thank you. Now a brief point of explanation. Dr. LaTourette has graciously agreed to be a part of this panel, but his main presentation will be in yet a different panel. And so this morning he will comment briefly on the rest of the speakers. So it falls to me to give the next presentation to be followed by Dr. LaTourette. It seems to me on this broad topic of fissile material that one of the most important aspects of fissile material is keeping it under authorized control. In 1986, a U.S. national intelligence estimate concluded that although terrorists could probably detonate a nuclear weapon if they gained access to sufficient fissile material, they were unlikely to do so because it would defeat their political objectives. Today, we live in an age of unlimited terrorism. If the attacks on the World Trade Center and the school at Fissile, to name just 2, have taught us nothing else, it is that today's terrorists are remorseless and bent on causing as much destruction as possible. For al-Qaeda, this includes an avowed nuclear intent. And although there have been significant reverses on al-Qaeda recently, we cannot be assured that that struggle is over. We also live in an age of greater access to nuclear weapons-related technology than ever before. There's more computing power in my iPhone than existed on the Mesa in Los Alamos in 1945. Computer-aided design and manufacturing give dozens of nations and thousands of facilities access to precision machining. More individuals today know the precise means of producing nuclear weapons than ever before. Unfortunately, the record for maintaining fissile material under authorized control is, in my view, somewhat shocking. The IAEA has documented about 20 cases of fissile material, or that is, highly enriched uranium or plutonium, escaping authorized control. These range over 2 decades, involving a few grams to a few kilograms of material. The latest was disclosed only last year. Clearly, we have a problem. The scale and severity of the problem is not known for certain because of a shocking failure of governments to investigate these incidents thoroughly. On the one hand, we can take solace that no case is known to have involved sufficient material to make a weapon, and the number of cases seems to be declining as efforts to improve physical security take hold. On the other hand, in all but one of the cases, we are apparently ignorant of most or all of the key details: where the material came from, how it got out, who removed it from authorized control, who abetted the theft, where the material was headed, and was there more material stolen. I would point out further that there is no case in which a government acknowledged loss of control of fissile material, which was later then found. In all of these seized cases, the governments, they had not been reported as losses, except for one of them. National efforts to investigate such cases are beset by secrecy, national pride, and perhaps corruption. International efforts, the IAEA and Interpol primarily, depend on the national efforts and to some extent have their own flaws. For example, Interpol's Operation Geiger covers both fissile material, as John had defined it, and radiological material, without a clear emphasis on the former, and until recently had only 1.5 full-time equivalents to handle the thousands of cases of reported incidents because radiological incidents were a part of their mandate. What is to be done? While I could offer detailed and specific proposals, and to some extent already have, I'd prefer to talk about the broad strategy, first of all. I would say first there must be a sea change in attitude, whereby more international opprobrium is attached to failure to investigate cases thoroughly than the evident failure that led to the loss of control in the first place. Governments must not be embarrassed about coming forward and acknowledging such incidents and getting to the bottom of them. Second, we must learn the lessons of past cases to ensure that leaks have been plugged. Who was involved? How did they do it? Have procedures been implemented to prevent future losses? Until we understand the past cases, we cannot be certain of our current security. This is not a matter of history, this is a matter of present-day security. Third, one lesson is already clear. Material in bulk form presents a special risk. All but one of the seizure cases involved bulk form material. Ingots, pits, discs can be counted and barcoded. Powders cannot. It can be accumulated in small amounts over time. Therefore, special emphasis must be placed on security at bulk material processing facilities in their design, physical security, control and accounting, and personnel security. With that, I'd like to open the panel to questions from the audience. Please.
Thank you. My name is Sonia Moreno from Argentina. I work in the nuclear regulatory body of my country. And about one of the presentations, the regional approach to enrichment and some of the multinational fuel cycle approaches. In the regional terms, I wonder whether this initiative would be reinforced by the issue of moving from the black box technology to a much more open situation between the countries that may be engaged in that cooperation. In our case, as it was mentioned, Argentina and Brazil decided to deepen the cooperation and the integration phase in which certain nuclear fuel cycle activities are being addressed together. The other thing is on the multinational fuel cycle approaches. One very challenging subject is how to ensure supply. These fuel assurances supply for countries that may be out of the region. So I wonder whether in the situation in which these initiatives may be outside of a region, how you would ensure that these supplies will take place at any instance. Thank you.
Dr. Brown?
I think that any regional approaches depend on the will of the countries in the region to engage in multilateral activity within the region. Whether a plant will be located inside the region or outside of the region depends on the nations interested in pursuing the multilateral approach. Sometimes it depends on how those countries want to assure that they'll have some access to enrichment technology and are willing to forego building the plants in their region in order to assure their ability to get technology. On some other occasions, nations are willing to have the international plant, enrichment plant, located out of the region because they don't trust each other. So it might be much better for them if the enrichment plant is not located in the territory of either one of them, so that there will be no concerns of one of them with the possible misuse of the plant by the host country within the region. Personally, I think that an organization like ABAC should be perfect for guaranteeing the safe operation of such a regional plant. The difference between ABAC and that kind of an organization is that in ABAC, Argentina and Brazil supervise each other's plants. in a multilateral fuel cycle center of whatever activity, enrichment, reprocessing, waste storage, or so on, all the participants will be watching one particular facility. So that's somewhat different than the ABAC model, but in principle it's the same. The ABAC model was a great success, and I was very impressed actually seeing in Argentina, talking with a young guy who told me that he's about to go on an ABAC mission to Brazil, and he's very happy about it. So I asked him, why are you so happy? Because he says, after we do the inspection of the plant, I could go to Copacabana and lie on the beach.
John, did you have a comment?
Yeah, I'd just add some remarks. I think there are two issues here. One is, can a known plant be misused by the host country? So I don't think that simply having a multilateral arrangement in itself is sufficient. You also need to look at issues of location and whether it's assessed that the host country might try to seize a plant, regardless of what arrangements apply to it. And that's one argument in favour of having black box arrangements, that even if the host seizes a plant, there would be a delay while that state figured out how to use the technology. That's one aspect. The other aspect is the risk of technology leaking. And the AQ Khan case that Will mentioned being an obvious example. And that too is an argument for a black box. And it's a point that would have to be watched very carefully in any kind of multilateral arrangement, that you don't want a multilateral arrangement that actually turns into an instrument of proliferation by virtue of a whole range of people from different states being able to get access to sensitive technology. So I think that's a point that has to be watched very carefully. On your other question, Sonia, about how to ensure supply, that obviously is a fundamental question. The Iranians point to Eurodif, for instance, as a failure in that regard. The Iranians were a shareholder, or still are, I think, a shareholder in Eurodif, but maintain that when they sought to draw down their entitlement to LEU, France refused. As a digression, I'd comment that's a distortion of history, that actually the Iranians refused to take supply which the French had rather foolishly offered them in 1980. But as by the by, I think the point with Eurodif is that it wasn't actually an international arrangement, despite Chime's remarks. Eurodif is a French company, totally under the control of France. It has international shareholders, but obviously the only recourse Iran had when it sought LEU was under French law, which means that it wasn't going to succeed. What we need in the future are arrangements that are genuinely multilateral, supported by treaty arrangements, where it makes it more difficult for the country that controls the material to deny supply. It still doesn't make it impossible, but it makes it more difficult if there would be treaty violations and maybe the involvement of the IAEA, maybe the involvement of the Security Council, and so on. And also, I think, as part of the supply arrangements, there need to be backup arrangements, so that, for instance, if you have the Angarsk plant in Russia, and security and supply arrangements tied to that as part of the arrangements that provide the umbrella for that operation, there would also be an enrichment plant somewhere else that would guarantee backup if Russia violates the basic agreement. These are all things to be explored, but I think we have to go down that path, because the alternative of having plants that are still wholly under national control, and we're going to have more and more of those if we keep down the current path, I think that becomes very dangerous for the effectiveness of non-proliferation and disarmament.
Before we take other questions, I apologize. I neglected to call on Dr. LaTourette for commentary on the other panelists.
Well, that's really all right. I mean, as often is the case, by the time everyone's spoken, there's very little left about this project, this problem that I know about that hasn't been said. Just a couple of comments. I come at this from the spent fuel management perspective, and I learned years ago people like to hear what they know, so I'll just state a couple blindingly obvious truths, and then we can move on. Intact spent fuel is the best, most proliferation-resistant material we've got, and it's important to remember that. This is, the plutonium's present at 1% in a solid, sintered oxide that's clad in zirconium metal, and so it's very physically and chemically hard to get at, and further, of course, it's self-protected by being screamingly radioactive. So you can't really handle it without protective shielding. And then we've heard about the different approaches to increasing proliferation resistance. I guess we don't want to use proof, but resistance. And I just want to add that these are often divided into intrinsic and extrinsic types of approaches. And I guess I find the line between them still a little fuzzy, but basically intrinsic means it doesn't involve any active acts of faith about people acting in a certain way. Intrinsic is it's built into the process. And so it's, of course, things like Urex or Urex Plus or pyroprocessing, other kinds of separation technologies that don't isolate plutonium. We all know, of course, the Purex isolates pure plutonium, not by accident, but, of course, a deliberate act. That's why we invented it, was to separate pure plutonium. But I would add to that there's also, advanced inventory monitoring and instrumentation, I think, is an important area that has been mentioned, but I just want to emphasize that if you can keep track of these atoms as they're moving through the line, and you get earlier warning than if you've got to do periodic inspections. Also co-locating partitioning and fuel fabrication facilities. This just eliminates the shelf life, eliminates the transportation step, and then whatever you do, it's important to remember you can't develop these technologies in isolation. This is a complicated process. You have to develop separation, fuel fabrication, and reactor design. All these things, none of them exist now. This is another important point. There is no Urex. There is no pyroprocessing. These are all lab bench kinds of things. But you have to develop this whole package together. And so how we think about this, you can't think about any part of that in isolation. They have to be coordinated. And then finally, going back to my original point, I think there is not a really particularly compelling case for reprocessing spent fuel at the moment. And given the great proliferation resistance of intact spent fuel, you might want to make that case a little bit stronger. The energy security uranium resource argument is questionable. Waste management arguments are, in my opinion, close to specious. It doesn't matter how much waste you have. That's not bothering anybody. And environmental dose, those arguments, again, are not really compelling. It doesn't really change the environmental dose of a waste repository to have separated, to reprocess and recycle. And if you were to do reprocessing, it's also important to remember this is extremely, extremely expensive, and there are gigantic economies of scale. And if you put a reprocessing plant in every country, nobody could afford to do it. So you would have to do regional, multinational operations anyway. And I think I'll just stop there.
Thank you.
Sure.
Ma'am.
I'm Ellen Lesen from the Stimson Center. You were the first to mention the link to terrorism, and it seems to me that since 9/11, the international community has invoked the fear of terrorists gaining access to weapons of mass destruction that have led to kind of new mechanisms, Resolution 1540 and its successors. But I wonder if the others on the panel have thought deeply about the plausibility of what a non-state actor would do if they accessed fissile material in terms of storing it, transporting it, using it. Doesn't this, are we really talking about a non-state actor as an independent, having an independent capability to do something with fissile material, or is it, have we a little bit spooked ourselves into thinking, I mean, I know about dirty devices, I mean, obviously they could try to immediately disperse the material in ways that would be harmful, but I wonder if others have questioned the credibility or plausibility of what a terrorist organization in a remote country without a lot of infrastructure could do with fissile material.
John?
I think it's an area that we can't afford to relax about. The main barrier against terrorist misuse of these materials is the difficulty of getting hold of sufficient material, and that depends on having security that is strong enough, and I'd argue it also depends on minimising the material so that you reduce the opportunities. There's no question whatsoever that if terrorists succeed in getting hold of a sufficient quantity of HEU, they could make any halfway competent group, subnational group, could make a functioning explosive device out of HEU if they have enough of it. You can make a very primitive design. Plutonium is much more complex and involves implosion technology, so that's more of a challenge to both treat the plutonium metallurgically into a form that will stay stable until it's detonated, and to make a functioning detonation system. But I think there are 2 points that are important. One is that terrorists, of course, aren't trying to make something equivalent to a deployable weapon. They're not interested in something that can be stored on a missile tip for years and will work reliably if launched when needed. Basically, all they want is something that will produce a mushroom cloud and a relatively small blast. A 10-ton yield in a city is going to have a huge psychological impact. Would change history, in my view. So if we think that terrorists need to produce 200 kiloton devices, we're fooling ourselves. Something very small will have the political impact they want. So that's one point. And the second point is, I think it's a mistake to think that that terrorists would be trying to do this entirely unaided. I think the real risk is that someone with expertise could step forward and help. And there are a number of disaffected individuals. We were very worried with the collapse of the Soviet Union as to where some of the key people ended up, and as it turned out, that situation was managed quite successfully, but it could have gone another way. Today we have individuals who are in the Iranian program, people who are in the North Korean program. Do we know whether those people might be willing to offer their services, either for money or for religious motivation, whatever? So that I think it could be a game changer if a terrorist group who has nothing but zeal and money is suddenly able to recruit someone who actually has some expertise to contribute, then I think we're in a totally different situation.
Dr. Brown?
Okay. Yeah, I want to say that we are living in the 21st century, where some sub-state organizations have got more power than actual other states. So we are talking about some very powerful sub-state organizations, example being Hezbollah, which has got more armament than an entire state. So the capability of those organizations to pose problems is more than people would assume some 20 or 30 years ago. That's first thing. Secondly, we shouldn't forget that international terrorism is, first of all, international theater. The whole idea is to create a political stir, get a lot of pictures in the paper, get lots of excitement, and try and produce a political result that the terrorist group has in mind. To that extent, there is no need even to develop a nuclear weapon device or anything else. It is sufficient if a terrorist organization captures a facility in which fissile material is enclosed and threaten to explode it or do something with it. And just stay in place, hold the material in the facility, and threaten unexpected consequences if the political conditions, be they whatever they are not met. The international theater that will come out of it might produce the political effect that those people are interested in, even without resorting to 10 kiloton or 200 kiloton or any other level of explosion. So it's possible to produce effect with minimal level of actually doing harm, and the capability of the organizations to do so has been increased as we gone along, let alone on such occasions where we have insider help that help those terrorists or subnational states gain access and gain control of a facility which includes nuclear materials.
Dr. LaTourette?
I think I don't really have a comment.
Fine. Sir? Yes.
Tobias Abe from Japan. I have two questions, one for John Carlson and for one. The first one is about plutonium. Now, I have in mind countries like Japan or Korea, who are in good standing today, but still under some suspicion, and want to improve the confidence. For that purpose, I understand if you have, if you burn uranium fuel longer, you have a greater portion of plutonium-240, which is more unusable for making bombs. So for that purpose, why don't you make those countries burn uranium fuel longer so that they can increase the confidence? Someone must have thought about this before, but what would you say? The other question is about to Dr. Brown. Uranium enrichment, indeed, if can be multilateralized, it's be better. But still, there will be few countries who still insist on national enrichment. There, I think the question, say I have in mind Iran or North Korea. The one question is early detection. If there's any hidden attempts to enrich, important question detecting. But I understand detecting enrichment is very difficult. Unlike reprocessing, it doesn't emit any radioactive material. Then, can there be any new technology to do so? And then the next question is, then you put IAEA inspectors there. The question is, if they go beyond low enrichment, the question is more political science. Can the world stop them? And so timely reaction, determined reaction to anybody who break out and go to high enrichment. So that's a question of sort of Security Council taking action in timely fashion. So what do you think about this?
Well, okay. Let me quickly talk about plutonium isotopics, and I have a bit of a reputation in this area. If those who want to Google the IAEA Safeguards Symposium paper that I wrote in 1991, I think, on the subject of plutonium isotopics, there's no doubt that higher burn-up material is less attractive for explosive use, but it's also a very strong position in the safeguards system that all plutonium, other than plutonium-238, is regarded as usable for explosives. I wouldn't want to be in a situation where we'd say, because of a higher 240 content, the plutonium is no longer feasible for explosive use. And personally, I think it's unlikely that a state would actually use reactor-grade plutonium for a weapon because of the reliability risks. I think it's unlikely, but it's not impossible. And it becomes a question of, would you call their bluff? You know, would you say, we don't believe those weapons will function, so we'll ignore the fact that you've got them? That's not going to happen. So even if you have your doubts about the effectiveness of a weapon, I think the possession of them will make a very powerful strategic point. So I think the problem is greater, though, with new reactor systems that can produce much higher 239 plutonium, and I'm talking about fast breeder reactors. Japan has taken the decision not to reprocess blankets separately. They're the very high fissile material, but to do the reprocessing in a blending operation to change the isotopic mix. I think that's a very helpful position, but of course it all depends on good faith. Simply turning a valve will change the isotopic output. India represents another extreme where the Indian three-stage thorium program involves deliberately reprocessing separately blanket material, supergrade plutonium, to use as driver fuel for thorium reactors. And personally, I think that's both a proliferation problem but also a terrorism problem. We were talking before, could terrorists make an explosive device out of plutonium? If they were able to get their hands on supergrade, that would be a great deal easier than using the plutonium that's in civilian use today. I think these are all arguments for looking very carefully at plutonium recycle systems. Plutonium recycle there's no doubt in my mind that plutonium recycle is a necessary thing in the future. And we have to find a way of doing it that minimises both proliferation and terrorist risk.
Dr. Brown?
Okay. I think the North Korean experience with the enrichment plant was very much telling about the possibility of detecting an enrichment plant. We know that the enrichment plant was located in a building that used to be a fabrication plant in the past. It was completely decrepit and destroyed. And then once the American and IAEA inspectors have left Yongbyon, within a scope of less than a year and a half, that whole facility was completely turned around. The building was completely renovated. A whole new centrifuge plant was built and installed. The control system was put in place. And when my colleague Sig Hecker and his friends came and visited it, the plant looked like it's completed and in operation within less than a year and a half. So it is amazing what could be done. Nobody expected it to be built and completed in such a short notice without anybody noticing it. This is not to say that there are no some signs that something could happen, but the speed at which it happened surprised everybody. There were attempts in the past to track export of forbidden materials into North Korea, material that pipes that were shipped from Europe, pipes that were shipped from Japan. So there was knowledge that experience or material and technologies were transferred from the outside to North Korea, though evidently the full scope of what been transferred has not been known before, let alone the control system, which is completely modernized with the latest Hewlett-Packard solid-state displays, which again, nobody expected them to be in a new enrichment plant, but they turned out to be there. So how did they get there? So export control, good as it is, in a place as secretive as North Korea, with some countries or some sub-state organization or corrupt individuals facilitating the transfer of technology, it is very difficult to find out. Iran is another example where it is difficult to find out exactly who all the suppliers are and to stop them. Sometimes you hear that there is an attempt to use the existing supply network that people know of and sell doctored equipment, which will eventually fail. That may or may not be the case, but it didn't prove completely successful. So global export control regime and tightening of the export control regulation, assuming that all the nuclear supplier group will abide equally in the requirements, will be a very useful tool. Can it be implemented to the same level of rigorousness in all the different countries? That's not clear. Powder material could be built on site. It is clear that North Korea knows how to produce margin steel and maybe even carbon fiber. They got the technical knowledge to do so. And we have no idea how many other facilities already exist in North Korea. It is clear that within a year and a half they didn't manage to build what they built without having previously had some kind of a prototype plant built somewhere else. On top of which, or based on that experience, they could build the actual enrichment plant that fast. So probably a facility half that size already exists somewhere in North Korea. And we don't know whether beyond this particular facility there may not be a second or a third or fourth facility lying somewhere else in some cave. Because of the small footprint, it is very easy to hide them. The only way is to look at some specific telltale technologies that might be expanded, like particular bellows, like vacuum pumps of special kind, like solid-state current controls, and like Samario magnetic rings. But even those are not completely possible to track, and therefore to say with 100% that we know that a facility cannot be built in any particular country would be evidently impossible.
We're drawing near the end of our time here, so what I'd like to do is take several questions, just the questions, as briefly as possible, and then offer each of the panelists a minute or so to answer those. So, sir?
Yes, Akira Tokihiro, University of Idaho, United States. I had a general question from the panel on knowledge management and knowledge preservation. You touched upon a number of topics. Coming from the university side, my main task is to educate and produce the next generation experts. But at the university, at the present time, we have it's a very open society. So I guess my question is, do you have a perspective on how the knowledge and technology education, should we manage that in some manner as a security issue? So far, it's not managed at all. So that's my question.
Yeah.
Hi, I'm Laura Salmon. I'm with the Carnegie Tsinghua Center for Global Policy. And just my response to all the talks today, it's really interesting. When you talk about this growth and international expansion of enrichment and reprocessing and thereby fissile materials, I'm struck by the fact that there's really no sign that China, India, these countries are backing away from their fast breeder reactor program. So I'm coming from China, and I know that no one seems to be headed in that direction. We're also talking about the importance of the Fissile Material Cutoff Treaty. Given the importance of this treaty, given this rapid expansion, have there been efforts, or can you actually combine this concept of a multilateral agency for supply and the Fissile Material Cutoff Treaty? Are they irreconcilable? Will it be a hindrance to negotiations, or can they be combined? And what are your overall responses to whether or not an FMCT is even possible?
Others? All right. I thought I had seen more questions earlier, but I guess perhaps those topics have been covered. John?
I'll pick up on the FMCT questions. Is an FMCT possible? Yes, it is. We already have a de facto fissile production moratorium for weapons use. none of the P5 have been producing fissile material for weapons for at least 15 years. There's a question mark about China's future intent. Certainly no interest on the part of the other four. The biggest problem in this area is with the non-P5, specifically India and Pakistan, that are both ramping up production. But I think myself it is possible to settle an FMCT at least amongst the P5 and then to try to bring India and Pakistan in later if it has to be done that way. That's not the ideal way to do it, but that's an approach. And at the moment, you're right, no one's looking at FMCT and multinational approaches as a package, but I think that's a logical way to proceed. I sort of hinted at it in my remarks. It's a logical way to proceed because it's in the future, if what are now the weapon states, and hopefully will cease to be so, still have the means to produce fissile material for weapons very quickly, and with a large enrichment plant, you're talking about the ability to produce HEU in a couple of days, basically. If they have the ability to reconstitute their weapons programs very quickly, that's an unstable situation, and I think it's a situation we have to move away from.
Dr. Brown?
Okay, so I'll pick up on the question of knowledge management for equity's sake. Evidently, knowledge management is the most important aspect of this, because these technologies, even though they are middle technologies, not very high technologies, still require quite a bit of knowledge of how to operate them. In the case of the North Korean enrichment plant, evidently, at least according to my colleague Sig Hecker, there was a direct assistance by Pakistan, and North Korean technical experts studied in the Kahuta plant and learned how to construct, design, and operate an enrichment plant. And that knowledge base was what made it possible for them eventually to design their own enrichment plant, procure the required material, and construct the prototype and then the full enrichment plant in a relatively short time. This is not the only example of knowledge management. I'll bring you another example. The Iranians had several different programs for laser isotope enrichment, which were all discovered in 2003 and stopped. The Iranians, of course, claimed that they encountered technical difficulties, and they stopped the program voluntarily because they couldn't fix the problems that were discovered. They got technology for laser enrichment from Russia, from Iran, not from Iran, from China, and for one or two other, some countries in Europe, and they claim that the voluntary stopped the program. My colleagues from the IAEA tell me that this is not exactly the case, because they knew or they learned what were the problems and how to fix the problem. So in the future, should they need to do so, they are in a position to resuscitate the program and presumably make it succeed. So evidently, knowledge management is an essential component of any proliferation program.
Tom, a brief word?
Just thanks so much. I think I probably learned as much as anyone.
All right.
So, thank you.
Well, thank you. That's entirely appropriate. I'd like to thank our panelists for excellent presentations and our audience for equally excellent questions. Thank you very much.